Hello grade 6 and welcome to our Wednesday video. With me as always is my sidekick, Berkeley the Wonder Dog. And Berkeley is relaxing after she just had a nice dinner. Berkeley, did you have dinner? Was it delicious? Oh yes. Are you excited about learning about math? Well, of course you are. Alright, so the reason I have my PGA Championship bucket hat on is because I love it. And because we have a EQAO math challenge. So, without further ado, if we look up our 3, which statement is true for these two rectangular-based prisms? So, we know it's volume, so length times width times height. We multiply that with our calculator if we want, and we get 1,600 centimeters cubed. And then, for this rectangular prism, 5 times 4 times 10, which will give us 200 centimeters cubed. So the difference between 200 and 1,600, if you wanted to simplify it, do 2 times 8 and transfer your zeros. Figure 1 has 8 times the volume of figure 2. So the answer for question 3 is D. And which of the following expressions represents the volume of the triangular prism? Well, we know that the volume of a triangular prism could be calculated base times height divided by 2, area of the base times the height. So the area of the base is 14 times 6 divided by 2 times 3. So that's the height. So if you answered C, you got the right answer. So I wrote down in paper all the right answers. So just to put them all in my bucket hat here. And I'll get back to the video. There we are. And okay, so our answer is Nick Hepburn. So congratulations, Nick. Nick answered on D2L. So I'm going to put my hat back on. I love this hat. So Nick will get a, I'm going to put it on right. Nick will get a Toblerone replacement prize when we get back to school. Okay, so for our video today, we are looking at calculating surface area. So if we look back to our previous lesson, remember that calculating surface area is calculating the area of all the faces, right? So if I take all the faces of this rectangular prism and I isolate them, okay? So I do each face with all its dimensions and lay them out for you, all right? Here we have, and you can think of it any way you want, right? This is the bottom, this is the top, this is the side, front, back, however, but we know that there are 2 faces that have the dimensions 6 and 3, right? So there's our 2 6 times 3 faces. And we have 2 faces that are 6 times 4, and 2 faces that are 3 times 4. So if we add all those up, these 2 faces will equal 36 centimeters squared. These 2 faces will equal 48 centimeters squared. And these 2 faces will equal 24 centimeters squared for a total of 108 centimeters squared. So I took all the faces, laid them out, calculated the area for all, added them, and we get our total. That's surface area. But that would take a while. So instead, what you can do is the math. So this was our second figure, the gaming console, if you will. And I just took each face, okay? So base of 3, height of 8. Okay, we know that each face on a 6-sided figure is going to have a match. So 3 times 8 equals 24. The other side, 3 times 8 equals 24. Okay, then we have our other dimension, right, which is 2 times 8, so 2 times 8, 2 times 8. right? And then we can call it the top and bottom if you want. Base of 3, height of 2, which means this is going to be a base of 3 and a height of 2. So I've taken all the faces and written the calculations for them. But there's a quicker way to do it. If you know that each side is going to have a match, instead of just doing it one by one, you can just times it by 2. So instead of going 3 times 8, 3 times 8, you know that it's going to have a match, so you just multiply it by 2. So 3 times 8 times 2, 2 times 8 times 2, 3 times 2 times 2. So you get those 3 numbers that represent all 6 faces. You add them up, 48 plus 32 plus 12, for a total of 92 centimeters squared. And it's centimeters squared because we're dealing with area. And if we go to the third shape, right, we could do it even quicker when we have square faces, right? Because they're the same dimension. So see what I did here? We know that 4 faces are going to have these dimensions, 12 times 2. So I did 12 times 2 times 4. And then 2 faces will have this dimension, 2 times 2. So that's just 2 calculations for a 6-faced figure. We add them up for a total of 56 centimeters squared. So again, it's adding up the area of all the faces. But today we're going to talk about triangular prisms. And how do we calculate the surface area for that? Well, it's the same as with rectangular prisms, okay? Except when we're doing the area of triangular faces, remember, we have to divide by 2. So remember this from volume? Well, now we're doing surface area, okay? So I did the same thing. I took this shape and I broke it down into its faces. So here are the 2 triangular faces. So if we're calculating the area of the 2 triangular faces, base times height, but we have to divide by 2 each time. So this would be 6 times 5, which equals 30, divided by 2, which equals 15. If that's 15, this is 15. So for a total of 30. Now the reason 60 is here is because I just added them both up, 30 plus 30, and then divided by 2. However you want to do it is fine. But the point is these 2 triangular faces, the area is 15 and 15 for a total of 30. And then the rectangular faces, okay, we have 3 rectangular faces that are going to be 9 times 6. Now, you're not always going to have an equilateral triangle as your face. It might be a different type of triangle. I'll show you what to do in that instance. But in this instance, it makes it pretty easy. Because we know that the dimensions for each rectangular face are going to be 6 times 9, 6 times 9, 6 times 9. All right? So when we total that up, it's 162 centimeters squared. We add the triangular faces to the rectangular faces for a total of 192 centimeters squared. So it's the same thing as calculating surface area for rectangular prisms, except when you're calculating the area of the triangles, don't forget to divide by 2. Okay? All right. So I talked about not all triangles being the same. So what I meant by that is, for example, this. All right. So this triangle here, again, if you think of it like a tent, this face would be 10 times 5. Pretend I'm pointing at this face. It's the same, 10 times 5. It doesn't even matter what the height of the triangle is here. It's okay. But I want to talk about the rectangle underneath. So if you think of the rectangle underneath this tent, it wouldn't be 10 times 5, right? It would be 10 times 6 or 6 times 10. This rectangle, remember, would have a base of 6 and a height of 10. Because not all sides of this triangle are equal. This is 5, this is 5, this is 6. So if you were to lay out all the faces of this shape, this would be 5 times 10, this would be 5 times 10, but the rectangle underneath here would be 6 times 10. And that's a really important distinction, okay? Because you'll get questions representing both. So what I did was, if you remember our, just to show you in real terms, right? I showed you our Toblerone bar. So that's what I used for volume, to show you area of the base times the height for a triangular prism. So here's another view of it here, right? Okay, so what I did to show surface area with the Toblerone is I cut it open. And when you cut it open, you get this. So what I did is I did the calculations for all the faces here, right? So 4 is the base, 3 is the height. I divided by 2, which gives me 6. Now there's 2 triangles, right? So it's a total of 12. So my base here is 4. My height of this rectangle is 10 centimeters. Why did I multiply by 3? Well, because there's 3 rectangular faces. I added them up, and there's the surface area for this triangular prism. All right, just to show you a real-world application of it. And then, of course, after doing all this work, and it is very challenging work. I won't mention to you how many drafts I've done of this particular assignment, this particular video, but well, it got me hungry. There's just no other way around it. It got me really hungry, and because I was so hungry, I thought I deserved a delicious Toblerone. So, to reward myself for all my teaching of triangular prism, I indulged. And I will remind you that the prize is not a Toblerone, so I did not eat Nick's prize. Don't worry, Nick. Don't get upset at me. Remember, when we go back to school, it's peanut-free, so it has to be a Toblerone alternative. So don't worry, your prize is safe. Okay? All right. So that is surface area of a triangular prism. I don't know if I like you to close this out. I think I have one treat left. So let's see if I can do it. So I like to close out with Berkeley. Berkeley, come get treat. Come on, Berkeley, eat treat. Oh my goodness, eat treat. Oh my goodness, it's delicious math treat. Okay, eat the treat really quick if you love math. Is it delicious? Is it delicious? Good girl. Good girl. Good girl. All right. So that's surface area of a triangular prism. I hope you enjoyed. Have a good day, guys. Oh, I forgot my call. Mr. Griffin out.